Welcome to the first video on the cube duplication solutions and the CGA series. Here looking at the solution. We expect to get results of this kind. I'm going to show how to generate a line of magnitude 1.2599 as I promised in the introductory video of this playlist. To help us generate these results, I'm going to use a dynamic geometry package called the GeoGebra, and that's what I've used in most of the presentations. I will open my GeoGebra software from this hyperlink. This is how the GeoGebra interface looks like, and we are in the right environment to perform our construction. I am going to pick 2 points, 1 unit apart. So I choose this point. Okay, I can pick that point. I'll base my analysis on use of coordinates, and then I draw a straight line to form the baseline. From this toolbox, I pick the straight line. Then I'll use another tool here for magnification so as to create a good field to do my construction from. That has moved so much underneath. Can bring it up this way. With that kind of distance between the 2 points, I'm ready to proceed with the construction. And before I initiate the process, I would like to raise the necessary tools for use in this construction. I will need to measure the distance. I will use the compass tool. I will do the perpendicular bisection, and yeah, those are enough. The rest will just be picked when the use is necessary. So I first begin by creating some points based on what I already have on the baseline. I have the B prime, which is an image of B about A, and A prime, which is an image of A about point B through geometric transformations. Using the compass tool, using this tool, I like to, I find this an easy way of constructing these perpendicular lines. So that's how I do it, that way. Now I come to pick the compass tool simply because I'm interested in 2 circles intersecting at a central point inside this figure, and the 2 arcs again should give me the remaining 2 vertices of my plane or my square. So this is how I do the remaining part of it in a very easy way. If you look at the results presented in the paper called the cube duplication solution by myself, you'll observe figures of this kind. So I label that as point C and that other point as point D. I will use a line segment to join these 2 points together that way. I also need to label this point of intersection as point E. Now using the line segment again, I join the point E to point D. That's okay. I can give this a different color. Let me choose a color like this kind of blue. They're just properties, and they make the figure sometimes look neat. Now I will use that tool to construct 2 other important points hidden somewhere here, and these they carry the properties I'm interested in for this construction. I zoom in slightly so that I can accurately label these 2 points here. I will need that point F and this point G. That's exactly what I have in my figure, the presentation on the paper on the cube duplication solution. These 2 points geometrically carry some very important properties. They will help me generate the results we are looking at, and in fact we are almost done. I'll use the compass tool, carry this EF, and placing my compass at point A, make an arc that cuts the line BA externally at a point H. I'll again use the compass tool, carry EG. Again at point A, I make another arc, and the 2 arcs appear to overlap each other or superimpose each other. They appear to lie on top of each other, but that's not the case. If I'm doing this on a plain paper in a piece So on a piece of plain paper and using pencil, there would be some kind of distinction in their placement. So what I do when the points are this close, you operate in the same manner. We drop a perpendicular through a point. So this point I is not well placed. I delete it and put it again. So I use another tool down here. Sorry, it is at this point. So this toolbox, I carry that and mark a central point I'm interested in. That point J, that's a point of interest. I can give this outermost a curve or circle a different color. Let me pick the reddish. That's it. And now I zoom out the figure to show you the results. We are done. I just needed the point G. It's that simple, that short to work with Alex's method. So when the points appear to be this close, you employ the technique of dropping a perpendicular through a point, and that's how you draw a line passing through the 2 points. I have these points J up to B. That's the distance I would like to measure. Since I had picked an initial length of 1 unit, that is 1.26, AB is 1 unit. I can magnify or stretch the scale, the accuracy into 4 decimal places maybe. And as you can see here, JB is 2.5. I can delete this one here. So we remain with 1.2599. And that's how simple it is to use Alex's method in doubling the volume of a cube. If I am to construct a cube of volume double this, then I should just pick the length JB and construct the face of the cube and that magnitude. That's how simple it is to use Alex's method in proving or justifying the cube duplication problem. From the scientific calculator, 1.2599 cubed is 1.999899. It's actually almost of a 99.9% accurate in terms of percentage. So that's one of the best results I'm expecting to get. Again, from the scientific calculator, the third root of 2 is 1.5992. So that is it. If I cube that, I get exactly 2. My result was 1.999899 in that order. So this is what I have, very close to 2, and some people would just use the word very close to imply it is not exact. Well, I'm not very sure you'll get anything exactly except from the theoretical arguments or theoretical view of the thing. Now, having seen the result, I'll go back to to my slides that way, and that makes the end of that very short video on the cube duplication solution. That is the general solution. As we have seen, that's how to use the Alex's algorithm in making the cube duplication solution a meaningful problem. In the next video, I'm going to take a real application of the problem using like 5 units magnitude cube, and you see the result you're getting. It should give us approximately 6.3. So that is what I'll perform in the next video for application. Thank you very much for following this presentation up to this point. Like this video and subscribe to our channel so as to get updated anytime I upload other videos of this kind. Thank you once again.